Hello, in this video we are going to be looking at different types of contingency table probabilities. It is very important to know contingency table probabilities because when we are given categorical data, we will definitely take advantage of learning more information about the data by using these contingency tables. So, as you can see here, we have distributions of conferred doctorates by field and gender in 2009. These are all doctorates. We have males and females, and then the different doctorates are engineering, physical sciences, life sciences, social sciences, education, and other. You'll notice that all the row totals and column totals are filled out for us. You'll also notice that the row totals here, sorry about that, the row totals here, this top one right here, 26,338 are the total amount of males in this study. The 23,190 stands for the total females that were in this study. Then looking at the column totals, the 7,629 were the total amount of doctorates in engineering, etc. 8,318 for the physical sciences, etc. So we're going to use the table to find and interpret each of the following, I'm going to erase these arrows first, probabilities. So we're going to look at the first one here. It says the probability of female and education. That word "and" means that this is a joint probability, right? Because we're not only going to be looking at education, but also female. Or we're not only going to look at female, we're also going to look at education. So then we're going to just go to the female education, and you'll notice this right here, 4,370 people in this study were female and education. The way we find the probability is we're going to go ahead and put it over the total of 49,528 students or doctorates that were in this study. So 49,528 goes in our denominator, and that 4,370 is going to go in the numerator. And then, of course, you can just go ahead and you can get a percentage there. Which equals about 0.088. Multiplying that by 100, we get 8.8%. So we know that the probability of someone from this study being female and chose education as their doctorate as 8.8%. Okay, we're going to go ahead and now look at B. In B, we notice this is the probability of life sciences given that the person is male. This is called conditional probability. Okay. The condition is that we only want to look at males. So what I'm going to do right off the bat, since we're only interested in the males, I'm going to just go ahead and cross out the numbers. I'm going to erase it in a few minutes when we get to C. And we only want to look at the males here. Now, what do we want to know about the males? How many of the males chose life sciences? So here we go. Here's the life sciences, 5,180. And we're going to divide it by the total number of males. And this will give me the probability of life sciences given that we're only looking at the males. So this is going to be 5,180 divided by 26,338. This is approximately equal to 0.197 multiplied by 100 equals 19.7%. So this lets me know that out of only the males, we're not including females here, 19.7% of the males chose life sciences as their field of doctorate. Okay, so now I'm going to go ahead, let's erase this so we can move on to C. Okay, now we're going to look at the probability of female given that they chose life sciences as a doctorate. So again, this is conditional. So you notice little clues to tell when it's joint versus conditional. In joint, you'll see the word and. In conditional, you'll see that slash. So here in the joint, we have the and in conditional, we have the slash marker there telling us that there's a condition on my probability. So let's look. We now only want to look at the life sciences. We do not care about engineering or physical science, social science, education, or other, or the row totals, but what we do care about is just the life sciences. Okay, so the number of females that chose life science as a doctorate was 6,212 divided by the total number of students that took that had life science as their doctorate. So this fraction here is going to be 6,212 divided by 11,392, which is approximately equal to 0.545 multiplied by 100. So this tells me that out of all of the students that chose life sciences, 54.5% were female. Okay. So you'll notice, be very careful with the differences between B and C. B, the condition is male, so that's why we looked at the row. And in C, the condition is life sciences, which is a column. Okay. Let's move on to the very last probability. This is going to be the probability of engineering. So we don't want to, no contingency, we don't cross anything out. We just want to know how many total students did engineering. We're not going to pinpoint it to male or female, just engineering out of all the students. So that is going to be 7,000. What was it? 7,629, all divided by that 49,528, which is approximately 0.154 or 15.4%. So this tells me that the number of students that chose engineering in this study is about 15.4%. Okay, so we did joint and conditional. This last one is what we call marginal probability. So hopefully this clears up any questions on the different types of contingency table probabilities that we can use. And I will see you guys in the next video.